Hi, everybody. Charles from GMAT Ninja here, and welcome to part 2 of our 24-hour nonstop GMAT crash course marathon, raising money for Ukrainian refugee charities. Hour number 13, kicking off with probability and combinatorics. We're not going to be able to be comprehensive with it in just an hour. What I'm getting at is, what do you really need to know? If your goal is a 47 plus on the quant section of the GMAT, what do you need on probability? What's the minimum you need to know to be able to get to that score level? And if you want to get higher, what do you need to do? So we're going to kick this off with a quiz once again. 5 questions, going to give you 10 minutes to do it. If you're watching this live, please go ahead and punch your answers into the Google form that's up in the links. That gives me some nice, fresh data. Enjoy that quiz. All right, looks like time's up. Here we are. Okay, so theme today, what is it that you're doing wrong in probability and combinatorics? Thing number 1 that I get all the time. So one of the fun things I used to do, especially in my earlier days as a tutor, was, back before the internet was much of a thing, now we handle everything over email, but people would call me and say, hey, I just took the test. I'm disappointed in my score. Can you help me? Have a conversation with them. They're walking out of the test center. It's the next day. And I'd say, oh, what do you think caused the trouble for you? And one of the things that everybody would say is probability, combinations, permutations. Hear it all the time. And after a while, I started to realize that the next question I'd ask was, well, how many did you see? And then they'd go, well, I guess 2 or 3 or 1, maybe 4 at the very, very most, back when the test was longer. But these are both fairly rare question types. Probability about 2%, combinations, permutations about 2%. You don't see a lot of them. And what do I really want out of these for most of you guys? If your goal is a 747 plus, let's say on quant, you can get a 47 handling just the basics. If you can handle the 5 questions we stuck into this quiz that are fairly foundational, you're in great shape. You don't need to be able to do the super crazy stuff. You don't need to be able to do the Buñuel level questions. So what I'm going to do in this hour, so we're going to go through the 5 on the quiz, since I'm seeing some pretty rough results. Looks like we need to go over some of the basics. We'll run through those pretty quickly. And then we'll kind of talk about, like, where's that line roughly as far as like what you really need if your goal is to kind of get into the 700s, again, get into the high 40s. Now, if you're somebody who has a compelling reason to get up, 50, 51, or you just enjoy it, knock yourself out. You can get really good at this stuff, and we'll have some more challenging questions, time permitting, towards the end of the hour. But one thing I want to be really, really clear about, if your goal is to improve your score on the GMAT, and unless you have some compelling reason to go for the super, super high quant score, you're applying to a program that demands it. If you're applying to just a normal MBA program where your study time is probably better spent elsewhere. So that 10 hours you spend on probability and combinatorics, spend 8 of it on verbal instead, or whatever your weaknesses really are. And something, again, I ask people all the time, students walk out of the test and, how much probability did you see? Yeah, sometimes 2, sometimes 1, sometimes none. Got some people weighing in on the comments that they saw none on theirs. Okay, now that I filibustered a little bit extra, how's the data looking? Not too rosy. Cool, good to know. All right, first question here, and I've got kind of 2 on the board right now in the interest of time. First one, board of directors consists of 10 members. Let me flash on the board real quick to refresh everybody's memory. 3 of those members are in leadership positions: president, vice president, treasurer. How many different ways are there to assign these 3 positions? Now, look, I think where the mistake is probably coming in here, difference between combinations and permutations. Permutation, I don't care so much about the jargon, but order matters, right? So if I'm talking about a code, if we're asking the question, how many ways are there to rearrange, I don't know, the letters A through E into a 5-letter code, something like that. Yeah, you're talking about order matters, right? So if you rearrange those letters, you get a different outcome. First thing you want to ask yourself, is this something where order matters or not? So if we have 10 people and we're going to go ahead and put them into these 3 positions, think about what happens if you have Buñuel, Evan, and Chuck. That is a much better company than if you have Chuck, Evan Buñuel, though he'd be a fantastic treasurer, he should be running stuff. So order matters, right? If you change the order, you get a fundamentally different company or different board of directors. So order matters. When order matters, it's a code, it's rearranging things. You could use a formula here. I don't necessarily mind if you do, but usually I think the most intuitive thing for most people, if you're struggling, is just think about it in terms of slots. Be intuitive. How many options are there for president? There's 10. Well, can't hold more than one position. How many options are there for vice president? 9 left. How many options for treasurer? 8. What to do with the numbers? Multiply them. Great, our answer is 720, which I believe is E. Now, what if I ask the question instead of saying I've got 10 people and we're going to make them president, vice president, treasurer? What if I ask instead 10 members? I want to know how many committees of 3 could be formed. Now, this wasn't the phrasing on the question you saw, but if I want to know how many groups of 3, now this is a combination. Order doesn't matter anymore. We're just saying, hey, you guys go form a committee, go over there, do whatever it is a committee does. I'm not a corporate guy. I don't know what committees do. And then we're using the nice little formula, n factorial over n minus k factorial times k factorial. If you've never seen this before, n is the number in your large group, k is the number in your subgroup, it becomes second nature really, really quickly. 10 in your main group, 10 factorial over 7 factorial, 3 factorial. And again, if you need to walk through the basics, we're going to have a separate videos on probability and combinatorics up on the GMAT Ninja YouTube page, YouTube channel in the next month or so, if you need to walk through the very, very, very basics. What we end up with here is a fundamentally different number. Can cancel pretty easily here, 1098 on top, divided by the 3 factorial. Cleans up pretty nicely, you get 120. Makes sense, right? Because if we're talking about rearranging these people, you should get a different number, a bigger number than if we're not rearranging them. The same 3 people can give you a whole bunch of different rearrangements, a whole bunch of fundamentally different companies. But if they're just saying, hey, go stand there on the other side of the room, fewer of them. Very easy to mix them up. I'm going to write something on the board real quick. I want you to delete from your brain for most of you. Again, unless you're already acing this, which I know some of you are, but I know from the data that a lot of you are not. Formula for permutation, I don't use this. So this is going to give you the 720. This is what you use when order matters. This is what you use when it doesn't matter. Now, I don't like this one bit. So again, some of you have technical training in this and you know it cold, fantastic. I'm not saying you should delete it from your brain. If you're new to this stuff, just put it out of your head. It's not intuitive. They look the same. If you memorize them, you don't understand them very well, you're just going to mix them up. You run a big risk of mixing up, especially under time pressure, especially if you're not studying this stuff a ton. And again, why should you? It's 2% of the test, maybe. So order matters. Watch you use slots. Order doesn't matter. Use that formula. Only one formula. Again, if you're new to this stuff, that's going to make it a lot easier on you. Okay, that's combinations, permutations. Question number 1, plus a riff on it. Question number 2, let me check the data one more time. Absolute bloodbath. That's fascinating. Okay, more than half of you missed it. Party on. Now, probability, again, I don't need you to be super stud of probability. You just don't need to know a ton of it. You're not going to see much that is that far past this unless you're way up in the upper reaches of the score range. And if that's the case, look, good for you. You can probably afford to miss it, right? So if you see anything that's much harder than this, you're in great shape. 3 apples, 3 mangoes. I'm going to select 3 without replacement. So thing 1, been preaching this whole time, read questions twice, which I know it's really annoying. It sounds ridiculous, but you miss those little modifiers. I see it happening all over the place. Every single session we do, I know some of you guys are tired too if you've been with us for all 13 hours. But just watch that stuff with replacement, without replacement. Without replacement, we're saying once we take one out, we're not putting it back in. So on these 3 trials, I'm going to get 3 different denominators. So first one, so pick 1 here. Yeah, I'm going to get something over 6. We'll talk about this more in a second. If I'm not replacing, I got 5 choices for pick 2. And I got 4 left for pick 3, and we'll get into the rest of it in a moment. So that's one concept that I have a really, really strong feeling is causing issues for some people. You're either not seeing it or not thinking through what it means. Issue number 1. And again, that's sometimes your general hygiene on quant. If you're not reading twice, plotting your path forward, maybe you're just going and starting to do stuff. Take a breath. Spend the extra 6 seconds. Read. All right. Probability that you get at least 1 mango. This is the other thing that to whatever extent you're going to see probability on the GMAT. Can't say it enough, a couple percent. It's not a ton of it. This is one of the preferred concepts. I don't want to oversell it and say you must know this, but if you're going to kind of get to a level where you're going to defend yourself against missing easier questions, it's probably something I expect you guys to know. What do you do with that at least one? I think this is a really hard question if you try to address this directly, because you can kind of get yourself into all sorts of trouble and go, well, okay, on the first pick, what if I get a mango, 3 out of 6, but then what does that mean on the second one? I could get a mango or not a mango. So is that 5 out of 5? But then what if this is not a mango, and then this maybe needs to be a mango, and now our brains are exploding and popping off and rolling down the street. Much, much, much simpler way to think about this. Think about what that phrase "at least one" means. It's the opposite of none, which is the most exciting thing anyone's going to say to you all day and all night. So what I mean by that is, well, think of it this way. Everybody watching this presentation right now either has at least one ostrich at home or has no ostriches. True statement, right? Either you have none or you have at least one. No matter what happens here from these 3 picks of the fruit, you're either going to get at least one mango or you're going to get no mangoes. So the probability of at least one mango, I'm going to erase this for a second, plus the probability of no mangoes, got to give you 1, right? Which means that all I need to do is get the probability of no mangoes, subtract it from 1, and I got the at least one mango, and you're out of there. So this is a heck of a lot easier to calculate. I don't have to sit there and break my brain going, well, what if the first one's a mango, then the second one doesn't need to be, but if it's not a mango, then one of the next 2 needs to be, and blah. Instead, really easy to calculate probability of no mangoes. So pick 1, probability of no mangoes. It's just the probability I get an apple. Great. Second pick, well, there's 2 apples left. 5 total things left. Third one, just 1 apple left out of 4 picks. I multiply all those guys together. Stuff cancels. It's great. 1 out of 20. That's probability of no mangoes, which means probability of at least 1 mango just has to be the complement, 19 out of 20. You're going to see this, again, probability and combinatorics both. This is one of the most frequently tested concepts. Again, in a fairly infrequently tested domain, but what I'd like you guys to be able to do, again, if your goal is high 40s or even mid 40s, defend yourself against missing a pretty easy one here and you're in business. All right. Question number 3. So just flashing it up here real quick. Let me check the stats. Sorry, you guys seem to do a little better on this one. And I guess this one isn't so complicated. Certainly mathematically it isn't. All right. So this is more of kind of a quick logical thing that I think cleans this up for you. So Ben and Ann are among 7 contestants from which 4 semi-finalists are to be selected. Of selections, how many contain neither Ben nor Ann? Really kind of a quick logical thing here. We're going to select 4. So ignoring the Ben and Ann situation for a second, we're going to select 4 from the 7. But once Ben and Ann are removed, we're still selecting 4, but we're selecting 4 from 5 now. Ben and Ann are out. And now, I mean, you could just kind of logic your way through it. Logic's a verb. Let's go with that. Because you reason your way through it and decide that it's 5. If you really want to, you could say, well, what I'm doing here is out of 5, I'm choosing 4. You could go back to this if you really wanted to. So 5 factorial over 4 factorial. Obviously, it's a little bit trivial to do the math, but you're going to get 5 either way. And that's that. Question number 5. Actually, let me check something real quick here. Yeah, okay. Yeah, that was about 60% correct on that one. Most successful of the whole bunch. And now number 4. Okay, if X is to be chosen at random from the set 1, 2, 3, 4, Y is to be chosen at random from the set 5, 6, 7, probability that the product will be even. Quick little bit of kind of basic, I don't know, I guess definition of probability, really. If you're fairly new to probability, if you're struggling with it, and again, looking at the data, I suspect that, probably about half of you have some basic struggles here. Just the vocal people on the live broadcast don't often. I think the issue might be that you're not really anchoring yourself in what is probability really? what we kind of get taught in school, especially here in the West, not universally necessarily, but a lot of us, it's like, I don't know, as a kid, it's like we just kind of multiply stuff together, and that's what probability is. And that's what most of us walk away with, or we walk away with absolutely nothing. Honk, if you're a Westerner and you feel the same way about that. So our temptation is just to kind of start multiplying things together. And I could do that here. So I could say, well, probability that xy is even. And now I can kind of start making some mistakes. So I can say, well, pick one. So this is for x. So what's probability that x is even? It's 1/2, 2 out of 4 in that set. So set x is 1, 2, 3, or 4. Y is in the set 5, 6, 7. Okay, so 1/2 probability I get an even one there. And then I pick from y 1/3 chance, and I can multiply them together. And I've got utter garbage. I'm not even close here, as it turns out. And now you can kind of start going down the road of, well, maybe I need to multiply something else. Well, what's the probability that that's even and that's odd? And you can kind of go down that kind of ugly sinkhole of just multiplying random stuff together, and then you start adding it. And easy to start making mistakes, too many steps, get yourself into trouble. I would take a simpler approach here, more intuitive, and just say, look, what's probability? And that sounds really, really silly. But again, speaking for Westerners here, certainly, what do we get taught probability is? It's multiplication randomly. That's what we get taught. That's what we take away from it. What is it really? It's the number of desired outcomes over your number of total outcomes. That's the definition. Don't think of it as a formula. Don't go memorizing this. That's not the point. That's what probability fundamentally is. I'm going to take this question off the screen. So if we think about the total outcomes, I'm picking one from here, one from here. My total outcomes has to be 12. Now, again, tons of ways to do this that are going to get you the right answer. And I don't think it is a problem if you do a different one here. But I'm kind of looking at this and going, what's my Trojan horse? If I try to do some kind of blind multiplication here, I can get in the business of, well, that 6 can be multiplied by the odd ones too, and you get an even number. And it's like, how about I just find the most efficient way to figure out how many desired outcomes I have? These are not large numbers. We got 12 total outcomes. That's it. I can probably just think my way through that and go, well, look, if y is 6, I got 4 outcomes where the product xy is even. That's 4 right there, where y is 6. Great. Okay, what are my other even possibilities? I've got the 2 here. We already counted 2 times 6. So I've got 2 times 5 and 2 times 7. That's 2 more. 4 times 5, 4 times 7, 2 more. And there's your answer, 8 out of 12, 2/3. And that's it. Again, other ways to do it. And that's one of the joys of the GMAT sometimes. One of the things that can be legitimately enjoyable is there's all kinds of different ways to solve it. They're trying to test you on, can you find the best way? Don't be afraid on probability. Again, for most of you, we're trying to be defensive. Get you to that 40, 47, 48 kind of score. Get this right. You don't need to be super fancy. You don't need to be able to do anything super advanced. This is going to do the trick for you. Sometimes dumb guy way is the best way. And that's all this is here. Again, other ways to do it, but no harm at all in doing it this way if you're struggling. Okay. Number 5 is actually quite a bit tougher, I think. Although you have proven me wrong. This is actually the second most successful question from the live group. So I stand totally corrected here. And one quick note here on this one again. Somebody just pointed out it's easier to count the odd numbers. And yeah, totally fair. How many ways are there to get odds here? Not very many. So that's totally fair as well. And that is an absolutely fine way to do it. Tons of ways on this, and that's kind of the point. Mid-level question, probably 6 or 7 different ways you could go about it. Find the one that works best for you. I don't need it to be synchronized swimming on probability. It's just not that common. This one I would think is a little bit tougher, but you guys actually did a little bit better on this than on most of the others. It was your second best question from the live group here. And maybe it is because it's pretty heavily algebraic. We got 9 blue. And the rest are red. I'm just going to say it's X red. And we're going to select 2 without replacement. And again, look, I screw this up all the time. I'm reading it twice every time. Am I sure it said without replacement? Let me think through what that means again. Always a healthy thing to do. The probability that both cards chosen will be blue is 6/11. What's the number of cards in the stack? So we know that this is going down. So I got pick 1, pick 2. I multiply those together, and I'm getting 6/11. All right, well, it's probably to get a blue on the first one. Again, if you need to anchor yourself in the idea that probability is just desired outcomes over total outcomes. Desired outcomes, I want a blue. How many total are there? Well, I got 9 plus X. Great. On the second pick, well, 1's gone. It's without replacement. So I got 8 blue left, 8 plus X left total. And there you go, multiply. You're going to get a fun little quadratic there. I'm not going to go through all the math. I don't need to spend the time on that. Cleans up pretty nicely. And there you go. You can have fun doing that, finishing that one up as homework if you're interested, but that's just some pretty straightforward algebra. All right. Final one. Wait a minute. Oh, I've got 2 number 5s in my list, which is not correct. Okay, I'm going to give you another one. It is listed as number 5, but that's not quite right. How much time do we have? We got about 20 minutes to go here. I'm going to give you 2 or 3 more of these. I'm going to start challenging you a little bit more, but honestly, this is kind of the end of the rainbow. If you can handle these 5 questions, I don't need you to be a whole lot better than that if your goal is 47 plus. Again, if you're going for that 50, 51, or you just love this stuff, knock yourself out. You know, we could have fun doing this for 3 hours and just keep throwing you waves of hard stuff. We can throw you waves of Buñuel's questions. I enjoy this stuff. I love teaching it. Actually, I love doing it. But for most of you, arguably a waste of your time. Okay. So again, we're past what most of you need. If you're going to be happy with the 650, 700, 47, 48 quant, you're good. You don't need this. What happens as you go from kind of the basics that I think you really do need for that kind of 47, 48 kind of score? And what is it that kind of happens as you go beyond it? Does it get more technical? Not really. There's a couple things where we can sort of say, well, that's sort of a specific way of thinking about it, where maybe, you know, as we look at these formulas, and I'm not going to spend time on it really, and we say, well, okay, permutation formula, combination formula. If I've got somebody who, actually I have a student right now who is, he's trying to get a PhD in finance. He's got to get a supersonic, super high score. He's going to study a ton of statistics. Yeah, I'm ramming this down his throat. He better understand this and understand why this is here. He needs to be able to basically derive it. That's coming for him. And for the score he needs to get into that program, yeah. Get into this deeply, really understand it. Most of you guys really don't need that. So in that sense, yeah, there is some technical stuff that's useful. And again, really fun, I think. But for most of you guys, yeah, what's going on? What makes it more difficult? There's very little that's technical. Usually it's just there's some little hitch that makes it not totally intuitive, or you got to kind of split it up in some funny way or something like that. So in this case, you know, my instinct is to start going, okay, I got a code. I don't need to use a formula here. I'm going to use the slots and kind of start punching in the potential number of things in there. So, okay, 10 digits. First digit can't be a 0 or a 1. So that leaves me with 10 things. So between 2 and 9 inclusive, 9 minus 2 plus 1 gives me 8. 8 options for that first spot. Now, here's the, I don't know, what I would actually do, or I think what I did when I first saw this question. 2, because there's 2 different options for the second digit. And then now these can't match, except it's not they can't match, they both can't be 0. So now it's getting kind of fiddly there. And I'm not sure what to put here. And I think that's where most people who might be fine on a simpler one are going to start train wrecking. And instead, what I'm going to do is I'm going to take 2 different cases. So version number 1 here is if this is a 0, it's the second digit. Now I'm not multiplying that. I'm saying 8 options here, and this is actually a 0. Then the third digit can't be a 0 in the same code. Well, great. That still gives you 9 options. Nice. So only 1 option here. That's got to be a 0. 8 options here, 9 options there. That means I got 72 different codes where you have a 0 in the middle spot. And now I can do the same thing where I say this is a 1, because that's the only possibility here for the second digit. Still 8 options here. Now we've got everything possible here for digit number 3. Just says they can't both be 0. If it's a 1, this could also be a 1, no problem, times 10. That gives you 80. 80 plus 72, you're out of here. And again, plenty of other ways to do it. This is the one that I think is kind of the simplest, most intuitive. And this is what you see as we start ramping up the difficulty a little bit. Is you just kind of got to find that way to unlock it. And that is a skill you can absolutely get better at with probability combinatorics both. But don't torture yourself over it. Lots and lots of questions where we can throw different wrinkles in. I can give you 30 of them. You're going to get better. And as you get to the 31st, you'll be better at it. You might not get the 31st one, but you'll get better at it. But again, for most of you, the question is, why would you do that to yourselves? If you want to. Ian Stewart, by the way, is another good guy to call. I think he really enjoys this stuff too. All right. Next question. All right. Put you guys out of your misery here. So again, I'm going to keep emphasizing this. Most of you do not need this question. It's fun to do. The stretch is really good, even if your goals are pretty modest, looking for, let's say, mid to high 40s. But it's also not that far out of reach. We're not going to go super crazy here on the hard ones. I'm getting that question from some people. Judging by the data I was getting on the first few, most of the crowd is struggling here. And I think that's what I'm seeing in the live chat as well, where I'm just getting a handful of people weighing in and saying they got it. And crickets for most of the rest, the occasional person who says, I'm getting my butt kicked. Okay. So again, one of the concepts they really like on the GMAT, to whatever extent you see probability in combinatorics, not a ton of them on the test, is at least one business. If you can anchor yourself in that logic, the whole question opens up to you and you say, okay, selections of 5 books that have at least one of each type. Okay, let's start with this first part, selections of 5 books. And that's irrespective of type for now. So how many selections of 5 books are there? 10 factorial over 5 factorial, 5 factorial. It's going to be a little annoying, but 10 times 9 times 8 times 7 times 6 over 5, 4, 3, 2, 1. A little bit annoying, not so bad. Cancel all that out. Cancel this out. That probably wasn't the best move, actually. Whatever, that's fine. Times 2, so I got 4 times 9 times 7 there, so 63 times 4. Somebody please check my math. So I'm on hour number 13, but 252, I believe. Hopefully that's what everybody's getting. So that's selections of 5 books. Now there's 2 kinds of selections of 5 books. There's the one with at least 1 paperback and the ones with no paperbacks. There's the one with at least 1 hardback and there's one with no hardbacks. So all I really need to do here is take that number and subtract out the ones that are going to be all one of a single type. So how many selections have with no hardbacks? Well, it's impossible. Choosing 5 books, you only got 4 paperbacks. It is absolutely impossible to get all with no hardbacks here. I was going to have 1. So this is 0. How many selections with no paperbacks? So that's all hardbacks. How many ways are there to do that? Not that many. 6 hardbacks, we're choosing 5. 6 factorial over 5 factorial, 1 factorial. If you want to get fancy, that's 6. So 252 total selections. There's only 6 of them that you don't want here. And that's it. Subtract out the 6 and you got it. Answer is 246. Answer is D. Okay. Do you have time for one more? Barely. I have one that's pretty quick. That one's pretty ugly. I wonder if we should just wrap this one up. Because I think everything I've got left here is pretty brutal, to be honest. Let's do this one real quick. Okay, so we're coming up to the end of the hour here. A screenshot if you need to, pause if you need to. So again, kind of the deal when you get a probability in combinatorics, there's the ones that are straightforward, formulaic. Say something like, okay, 10 people, going to make 3 of them, form a committee of 3, nice formula, nice and clean. What makes these harder? It's not super technical. It's just things where you kind of have to think through sort of how to arrange it, has sort of an element of reasoning and kind of rearranging, and maybe there's different scenarios you need to take into account. And maybe those scenarios operate a little bit differently. Maybe it's a little bit tough to kind of see the way to unlock it. And I'm getting some really fun comments now where people are like, E, no, wait, now I see it. It's not E. as you kind of look at this long enough, maybe something kind of dawns on you. Pretty typical. Again, how many of these do you need to get right? Very, very few. The thing most people are doing wrong with probability and combinatorics is overdoing it. Again, unless you have a compelling reason to, don't kill yourself over it. 3 people, 2 offices. Offices can be empty. So we could have 3 here, 0 here. There's no further ways to rearrange this, right? 3 people here, no people there. So that's one way. There's another way. 0 people in office 1, 3 people in office 2. And then you could have 2 and 1 and 1 and 2. And the temptation here might be to say, well, the answer is 4, which isn't one of the answer choices, which is very nice of them. But now as you think about different ways you can rearrange this, that's where things get a little more interesting, because you could have 3 different individuals here. So this is one way, no different ways to rearrange these 3 people in the office. One way here. And then if you think of this as 3 separate people, again, it's Buñuel, Bogdan, and Doug. They all could be in office 2. So 3 different ways to arrange it with 1 person in office 2 and 2 people in office 1. Same thing here. I think the easiest way to think about it intuitively is to say, same deal, 3 people, Buñuel, Doug, and Bogdan. 3 different ways to arrange, or 3 different people you could put in that first office. The other 2 would be stuck here either way. 3 ways, add them up, and you get 8. And that's your answer. Answer is D. Okay. So one of the questions I'm getting here real quick. So it says that some of the offices can be empty and more than 1 employee can be assigned to an office. But all of these 3 people have to be arranged in these 2 offices. So that's the hitch here. These 3 people all have to go somewhere. Okay. That is it for this hour. Thank you so much for watching.